Have you ever wondered why Venus, our closest planetary neighbor, is often referred to as Earth's evil twin? This celestial body, veiled in a thick, swirling atmosphere, is a world of extremes. It's home to a runaway greenhouse effect that traps heat, pushing temperatures high enough to melt lead. The surface of Venus is a fiery inferno, with conditions harsher than the deepest abyss on Earth. Over the years, our curiosity has led us to dispatch several missions to this mysterious planet. Notable among them are NASA's Parker Solar Probe, designed to touch the Sun, but also gathering valuable data on Venus, and ESA's Venus Express, which spent 8 years studying our tempestuous neighbor. These missions have helped us understand Venus's unique characteristics, its composition, and its atmosphere. But many enigmas remain. So buckle up, space enthusiasts, as we embark on a thrilling journey to explore the enigmatic world of Venus. Imagine an atmosphere 92 times denser than Earth's, with clouds of sulfuric acid and surface temperatures hot enough to melt lead. Yes, we're talking about Venus, Earth's closest neighbor, and a planet that's truly a world of extremes. As we dive into the thick, turbulent atmosphere of Venus, the first thing we encounter is a dense layer of carbon dioxide. This isn't a trace amount, mind you, but a whopping 96% of the entire atmosphere. This carbon dioxide blanket traps heat, creating a runaway greenhouse effect that makes Venus the hottest planet in our solar system, even hotter than Mercury, which is closer to the Sun. Now, if a stiflingly dense atmosphere and scorching temperatures weren't enough, Venus has another surprise up its sleeve. Suspended in its upper atmosphere are clouds, not of water vapor, but of sulfuric acid. These clouds perpetually shroud the planet, making it impossible to view its surface from space with visible light. This lethal cocktail of carbon dioxide and sulfuric acid creates an environment that's not just inhospitable, but downright destructive to most forms of life as we know it. And it doesn't stop there. The atmospheric pressure at Venus's surface is the equivalent of being about 3,000 feet underwater on Earth. That's enough to crush many submarines. But what does all this mean for human exploration? Well, the conditions on Venus pose significant challenges, to say the least. Any future missions to the planet will need to withstand not only the extreme temperatures, but also the corrosive sulfuric acid in the atmosphere and the crushing surface pressure. Despite these challenges, Venus continues to captivate us, serving as a tantalizing destination for future exploration and a potent reminder of the potential consequences of a runaway greenhouse effect. So, as we gaze upon the brilliant morning star that is Venus, let's remember the harsh, unforgiving world that lies beneath its radiant exterior. Venus's atmosphere presents a world of extremes, a stark reminder of the power of the greenhouse effect. Beneath the torrid atmosphere, Venus reveals a surface shaped by volcanic activities and deformed by intense pressures. This world, often dubbed Earth's evil twin, is a stark contrast to our home planet. The Venusian landscape, dominated by volcanic plains and colossal mountain ranges, paints a picture of a world in constant turmoil. The planet's surface is a testament to the forces at work, with over 1,000 volcanoes scattered across its terrain, some dwarfing the size of those found on Earth. Yet, despite its extreme conditions, Venus is not a static world. Recent missions like NASA's Parker Solar Probe and ESA's Venus Express have unveiled new facets to this enigmatic planet. For instance, these missions have found evidence suggesting that Venus may still be geologically active. Yes, you heard that right, Venus might still be a living planet, with lava flows that could be just a few years old. The Parker Solar Probe, while primarily aimed at studying the Sun, had a chance to observe Venus up close during its gravity assist maneuvers. It detected a natural low-frequency radio signal, a telltale sign of Venus's electrically active upper atmosphere. Meanwhile, the Venus Express mission has provided data suggesting that Venus's rotation rate is changing, an intriguing detail that may be connected to its weather patterns. The lack of water on Venus, however, remains a significant contrast to Earth. The planet's surface temperature, hotter than a conventional oven, ensures that water, if present, would quickly evaporate. Yet the discovery of phosphine, a gas often associated with life, in Venus's atmosphere has raised eyebrows and sparked debates in the scientific community. From its scorching atmosphere to its volcanic surface, Venus continues to captivate and intrigue scientists, offering both cautionary tales and tantalizing mysteries for future exploration. As we continue to probe the depths of our solar system, Venus, with its harsh conditions and surprising hints of activity, serves as a stark reminder of the diversity of worlds that exist just a stone's throw from our own.